Welcome to my YouTube channel Math Sikshak. In this presentation, I will highlight the significance of trigonometric identities. In calculus and all its applications, trigonometric identities are of central importance. Let me begin my presentation by focusing on the word identity. An identity is an equality that is true for any value of the variable. As we proceed further, you will be able to distinguish between an identity and an equation. My presentation focuses on an introduction to trigonometric identities, reciprocal and quotient identities, and Pythagorean identities. Let me now bring to light how trigonometry has been into action from the Egyptian time. So what type of pyramids did the Egyptians build? The ancient pyramids were regular square pyramids. That is, all the sides are equal and the base is a square. They did not use angles to measure the slope. Instead, they used cotangent ratio. Another very good example of the usage of trigonometry is in our solar system. Since the ancient time, human beings have observed the sky, the movement of sun, stars, moon, and planets within it. Several hundred years ago, the approximate distances between the planets was determined through trigonometry. In trigonometry, trigonometric identities are of central importance. So what do we mean by a trigonometric identity? Trigonometric identity is a composition of trigonometry and identity. Trigonometry because it's the usage of trigonometric ratios, and identity because for any value of the variable the equation remains the same. So trigonometric identities are equalities which will involve trigonometric functions and will be true for every single value of the variable. For example, cot A is equal to cos A by sin A. Sin square A plus cos square A is equal to 1. This is a trigonometric identity because we are using trigonometric ratios sin A and cos A. And for every value of A, this equality is valid. Therefore, this is a trigonometric ratio. Similarly, cot A is equal to cos A by sin A is a trigonometric identity. So now what is the difference between an identity and an equation? Identity is an equation as for every value of the variable the equality remains. But that is not the case in an equation. Let me now explain to you some of the fundamental identities. They are the reciprocal identities, the negative angle identities, Pythagorean identities, and quotient identities. Let me begin my explanation with reciprocal identities. So what do we mean by a reciprocal identities? The trigonometric identities defining cotangent, secant and cosecant in terms of fundamental trigonometric ratios, then they are called as reciprocal identities. So when we try to express the cotangent and secant as 1 by the fundamental ratio, trigonometric ratio, then that identity is called as the reciprocal identity. For example, cosecant A is 1 by sin A. So I'm writing it as 1 by, and this is a fundamental trigonometric ratio. So I'm writing cosecant A as 1 by sin A. So this is cosecant A is a reciprocal identity. Similarly, secant A is equal to 1 by cos A. So it's again a reciprocal identity. Now, let us try to understand the next type of identities, that is quotient identities. So what do we mean by quotient identities? If I am able to express a trigonometric ratio as quotient of trigonometric ratios, then that identity I call it as a quotient identity. Let me explain to you this with an example. Tan A is equal to sin A by cos A. So I am able to express tan A as a quotient of two trigonometric ratios, that is sin A by cos A. Therefore, this identity, that is tan A is equal to sin A by cos A, is called as a quotient identity. Similarly, cot A is equal to cos A by sin A. I am able to express the trigonometric ratio as a quotient of two trigonometric ratios. Then it is called as a quotient identity. Proceeding further, let us now try to understand Pythagorean identity. So what do we mean by a Pythagorean identity? So if I am able to express the Pythagoras theorem, in terms of my trigonometric ratio, then that identity is called as the Pythagorean identity. And the very basic relationship is sin square A plus cos square A is equal to 1. This satisfies the Pythagoras theorem. And based on this, we have our other identities. 1 plus tan square A is equal to secant square A. 1 plus cot square A is equal to cosecant square A. All these three identities satisfies the Pythagoras theorem. And the Pythagoras theorem being satisfied with the usage of trigonometric ratio, hence it is called as Pythagorean identity. So what is the Pythagoras theorem? The hypotenuse squared is equal to the sum of the squares of the other two sides in a right angle triangle. Now, let me illustrate to you how we can simplify trigonometric expressions using our fundamental identities. Let me take this first example. Sin cube theta plus cos cube theta divided by sin theta plus sin cos theta. So I am going to apply the various identities that I have learnt and simplify this trigonometric expression. So first thing that I do here is apply the formula for my basic identity a cube plus b cube. So a cube plus b cube is equal to a plus b into a square plus b square minus ab. So sin cube theta plus cos cube theta is sin theta plus cos theta into sin square theta plus cos square theta minus sin theta cos theta whole divided by sin theta plus cos theta. Simplifying further, we get it as sin square theta plus cos square theta minus sin theta cos theta. So we have just now learned the Pythagorean identity. Sin square theta plus cos square theta is 1. So simplifying it further, we get it as 1 minus sin theta cos theta. So this is the way we need to apply the various fundamental identities that we have learned to simplify trigonometric functions. Proceeding further on into another example that helps us to understand how we need to simplify trigonometric expressions. Sin theta by 1 plus cos theta plus 1 plus cos theta by sin theta. We need to prove it to be equal to 2 cosecant theta. So we consider our left hand side first. Sine theta by 1 plus cos theta plus 1 plus cos theta by sine theta. So now when we see that these two expressions have two different denominators, we bring them to a common denominator by multiplying them. So it's sine theta into 1 plus cos theta. So how do I simplify it? It's just like how we cross multiply and do. So it's sine theta into sine theta plus 1 plus cos theta into 1 plus cos theta, whole divided by sine theta into 1 plus cos theta. So that becomes sine square theta plus 1 plus cos theta whole square by sine theta into 1 plus cos theta. Sine square theta plus a plus b whole square, applying the algebraic identities formula, that's a square plus b square plus 2ab. So it becomes 1 plus cos square theta plus 2 cos theta whole divided by sine theta into 1 plus cos theta. So now let us see how we apply a Pythagorean identity here. So sine square theta plus cos square theta can be written as 1. So it is 1 plus 1 plus 2 cos theta whole divided by sine theta into 1 plus cos theta. So that is 2 plus 2 cos theta whole divided by sine theta into 1 plus cos theta. So we can take out 2 common. So it's 2 brackets 1 plus cos theta whole divided by sine theta into 1 plus cos theta. Simplifying it further, we get it as 2 by sine theta, that is equal to 2 cosecant theta. So 1 by sine theta, that's again a reciprocal identity. So that becomes 2 cosecant theta. In my further videos that I will be uploading, we will go into detail of simplifying trigonometric expressions. For any suggestion, feedback or queries, please contact us at mathsikshak@gmail.com. Please subscribe the channel. Thank you for patiently listening to my video. Thank you once again.